Hey everybody, welcome back to the ECG of the day. My name is Reed, and don't forget that you can download the PDF down from the description below. It's linked. And don't forget to like this video and subscribe to the channel if you enjoy the content. So let's jump into it. So the first thing I like to do is I like to look at the forest, and the trees of the forest are my QRS complexes. And so I maybe look down here at lead 2, and I notice I've got a narrow complex rhythm that seems to be marching along pretty regularly, and it does so until we have at the end kind of this funky looking beat with what seems to be a little bit of a pause after it until we can see maybe something happening at the end. And the other thing I notice is that maybe this is not the most regular to start with, right? See, this is kind of a longer gap than before. So we can kind of investigate that and take a look and see what we think. So first thing we're going to do is we have a narrow complex rhythm, so we think that probably this is coming from the AV node down the His-Purkinje system, and I do notice that there are P waves in front of my QRSs, and so that makes me think that atrial depolarization is driving this rhythm. What's the rate? I would say the best ones, if you're going to go from R to R interval, is probably like one of these middle ones, but what I'll do just for the sake of this is I'll count all of the QRSs on this 10-second strip and multiply it by 6. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so 10 times 6 is 60 beats per minute on average. So that's about our average rate. You do that when the R to R intervals are a little bit irregular, right? And we could say that we might have that here. So we've got a rhythm at 60 beats per minute with P waves. Okay, well, what does P waves look like? Well, it seems like those P waves are upright in lead 1, and it also seems that they're upright in AVF, so that tells me that these are sinus P waves. Okay. Next thing that happens is my AV node takes that signal and it sends it down the His bundle down to the ventricles, but it usually delays it by a little bit, so we can look at that PR interval and see how long is it delaying the signal for. And my PR interval measures in between 120 and 200 milliseconds, which is 3 to 5 little boxes, so that's good. And you can see that with every P wave, the next QRS comes right on time, so that PR interval stays the same. So my AV node is functioning well. Next thing I want to do is evaluate my QRS complex. My QRS was narrow, right? If I measure the width of my QRS is less than 120 milliseconds, or 3 small boxes. That's rapid. It makes me think that it's going from the AV node down the His-Purkinje system through the ventricles rapidly, right? That's what creates time on the x-axis being narrow. Those QRS complexes are upright in lead 1, and they're downgoing in AVF, and so that means they're going up and to the left, and they're a little bit more positive than negative in lead 2. So that means that my QRS axis is somewhere in maybe this quadrant, right? Somewhere between 0 degrees and negative 30 degrees, right? Because if it's negative in AVF, it has to be going at least up, but it's still positive in lead 2, so this is the quadrant, right? Okay, so we have what we would call left axis shift, which can be, just a common finding. You might, I wonder what it's from. We'll see. And so we have that. We look at our QT interval, right? So I look maybe in between 2 R to R intervals here. I find the midpoint. I make sure my T wave ends by that point, which it does, so it's a good QT interval. Last thing I'll do for this is I'll look for any pathological Q waves, previous myocardial infarctions, and I'll look for any active ST or T wave changes, depression or elevation for any active ischemia or infarction. Really the only thing that I note is maybe we have some Q waves here, maybe some inferior Q waves, so possible inferior old MI, right? And that might explain my left axis shift, right? If a little bit of the myocardium that's represented by lead 3 is damaged, well, my signal isn't going to be able to go that way. It's likely going to kind of, on average, go a little bit more to the left, right, throughout my QRS. But no active ischemia or infarction. And so the last couple of things we need to do is we need to see if we can explain this pause, right? And it's hard to say, right? This is a little bit of a sinus node that seems to be beating a little bit irregularly. This P wave looks a little bit different than the normal P waves if you compare it to the normal P waves. So it looks a little bit more broken, but it's similar. So maybe we could say that this is like an ectopic P wave, right? We might be able to say that. So that might explain a little bit of the pause. So maybe an ectopic P wave, it's hard to say. And then we need to explain this beat right here, right? And so we have a wider complex beat, right? If I look right here, you can see my QRS. My QRS is probably about 100, maybe 40 milliseconds. Regardless, it's wider than the normal QRS. It makes me think that it's not going through the normal His-Purkinje system. So that can be a PAC with aberrancy or a premature ventricular contraction. And so what I need to do is I need to look in front of it, and I need to see, are there any atrial P waves in front? I don't see any. I compare it to the previous ST segment. I don't see any. And so that would make this a premature ventricular contraction. And actually, if you look just beyond the PVC, if you see this little deflection, that's actually a retrograde P wave. Notice that retrograde P wave is negative in lead 2, right? It's negative in my inferior lead. So likely what happened is we have a PVC that maybe arose from right here, right? And it fired off. I'm not going to actually figure out exactly where it went, but it goes through from gap junction to gap junction, slowly creating a wide complex QRS. And then in some people, their AV node is actually able to take that signal and send it retrograde. And so then at the end of it, we'll see a retrograde P wave that is sitting on the ST segment of that PVC, and that's exactly what we see. And so because of that, that retrograde P wave will depolarize through the atria. It'll stun the SA node for a split second. You'll get a little bit of a pause, and then you see the sinus node begin again. So that's why we get a little bit of a pause. It's kind of like we would call that maybe a compensatory pause. Okay. And so what do we need to do to put this all together? What do we have? A sinus rhythm with a rate of maybe on average 60 beats per minute. We've got left axis shift that might be explained by potentially a pathological Q wave in lead 3. We've also got potentially an ectopic P wave and a premature ventricular contraction with actual evidence of retrograde P wave and a compensatory pause. So I hope this helps. If you have any questions, feel free to reach out, comment, email. And if not, thanks so much for supporting the channel. I hope this helps, and have a great day. Take care.